We're working on number 4 on page 2 of the 5.1 notes. So to find the domain of a rational function, which is just another way of saying fraction, we set the denominator equal to 0. We look for a factoring pattern. This is a difference of squares, so we do different signs and then square roots. Then we use what we learned in chapter 4. If a times b equals 0, then either a is 0 or b is 0. Solve each one and we get our 2 excluded values. That means we have to exclude them from the domain because they make our fraction undefined. They make the denominator 0. So we call them excluded values, or some textbooks call them undefined values. So what that looks like on a number line is we can pick any number in the world except -2 and +2. And when you go to graph them on your number line, make sure you put them in the right order. You can't just put them anywhere. This is a number line, so they have to be in number line order. So we put circles to show they're excluded. I put my negative and positive infinity in so that would make it easier for us to write our interval notation. Remember, interval notation is exactly in the same order as the number line with u's in between. So our first interval would be negative infinity to -2, parenthesis, united with -2 to +2, parentheses. Remember, the parentheses exclude the excluded values, which is what we want. United with 2 to infinity. So that would be the interval notation. Like I said, if Alex has you draw the graph second, do the graph on your page first, because I can tell you the most missed thing by this, one of them, is students write these values instead of setting them equal to 0. They get lazy and go, oh, it just can't be this and this. The other thing is they don't do the order correctly because they don't do the number line first. It has to have this exact same order. It has to have the U's and it has to have parentheses. Okay, on the other page, we learned for set builder notation, you write for all x such that, you use the letter that's given in the problem, for all x such that x is a real number comma, x cannot equal -2, comma, x cannot equal 2. And that's how we write the set builder notation. So x is a real number, except x can't be -2 and x can't be 2. Okay, the next one's on the test. Since we did one just like it on the other page, why don't you go ahead and shut off the video and try this one on your own. Okay, step 1 is to set your denominator equal to 0. And remember what I said, if your middle term does not have a number in front of it, write the number 1 so that when you're doing the next step, the factoring step, then you say factors of 12 that subtract a 1, which would be 3 and 4. This is a double bubble because the leading coefficient's 1, so I can go right to the answer. This says the signs will be different. And this says make sure the larger number is negative. So I go over here and say -4, +3. So they're different, and my larger one's negative. So x plus 3, x minus 4. Remember, no AC required on double bubble. You can go right to your answer. Okay, next we have If A times B equals 0, then either A is 0 or B is 0. So I solve these two equations to find my two excluded values. And they're excluded, remember, because they make the denominator 0. You can plug them in and see. -3 times -3 is 9. Minus -3 would be +3. 9 plus 3 is 12. Minus 12, sure enough, it makes the denominator 0. We can never have 0 in the denominator of a fraction, therefore it's an undefined value or excluded value of the domain. So those are the two values that x can't be, and you can test for. 16 minus 4 is 12. 12 minus 12, 0. Yep, it makes it 0. So in the proper order, put those two values on the number line. Circle the values that are excluded. Shade everything else in to show any number works for this function except for the two that are circled. Everything else works. And then I like to put my negative and positive infinity in because I notice a lot of times students will leave the signs off when they go to write them. So if you put them on the graph, you're probably not going to leave them off when you go to write them. So to write my interval notation, I keep it in exactly the same order. Write my three intervals with a u in between. So negative infinity, comma, -3, united, -3 to 4, united with 4 to infinity. So there we have it. And for set builder, we just do the same thing we did on the last one for all x, such that x is a real number. I'm just going to abbreviate since we're running out of room here. X cannot equal -3, comma, x cannot equal 4. And there you have it. So you're going to see that one 2 more times. Number 1 on your next test, and then on your final exam. Okay, let's practice on a couple other ones. Let's do 7 first, and then we'll do 6. Because 7's a nice one. 6 is kind of a special case, so I would rather make sure you have the problem down before we start doing some special cases. So for number 7, step 1 is set the denominator equal to 0 because we need to learn what values are undefined. Don't forget, two terms is either GCF, squares, or cubes. That's your only choices when you see two terms. There's no GCF, but boom, they are squares. So this is a difference of squares, which tells me my signs will be different. And then I do square roots, x plus 6, x minus 6. So then we say if a times b equals 0, either a is 0 or b is 0. So our two excluded values are -6 and +6. And you can put them in and easily see both of those values make your denominator 0. So put them in the proper order on the number line, circle. So x can be anything to the left of -6. It can be anything between -6 and 6. And it can be anything to the right of 6. The only two values it can't be are -6 and +6 because they make the denominator 0. So now we write our interval notation, which is -infinity, comma, -6, just keeping it in the exact same order, then a union symbol, -6 to +6, then a union symbol, 6 to infinity. So you can see interval notation is so easy if you draw the graph first. It's hard if you're trying to imagine in your head the order, but with the graph, you just bring everything down in the same order, put union symbols in between. So for set builder, we'd say for all x such that x is a real number, x cannot equal -6, x cannot equal +6. So this means any number in the whole world except those two. Anything else works. Fractions, decimals, repeating numbers, radicals, anything works, just not those two values because they make the denominator 0. Okay, let's go ahead and look at the special case. And you're probably like, how would she know that's a special case? Well, I think you probably know too from your last test, x squared plus 3. So when there's two terms, our only choices are GCF, nope. Difference of squares, nope. Some are, excuse me, some are difference of cubes, nope. So this one doesn't factor. So then I go, whoa, what am I going to do then? Well, you have to think, what would make this denominator 0? So I look at this and I go, anytime I square something, -2 times -2, +4. -3 times -3, +9. Anytime I square something, it's a positive, and I'm adding it to another positive. Could that ever be 0 when I add two positives? Can a positive plus a positive equal 0? Never. Because this has to be a positive. This we can see as a positive. That's never true. So do you know what that means? Nothing will make this denominator 0. Nothing real. We will find out later there'll be imaginary numbers that work. Okay, let me get a drink. Sorry about that. So a positive plus a positive is never equal to 0. That means there are no excluded values. Because the denominator can never equal 0. Does not equal 0, ever, unless we put an imaginary number in, which we're not talking about right now. We're just talking about the real numbers. So because it has no excluded values, guess what the number line looks like? Everything. So every number in the world works because there's no excluded values. So that means my interval notation is simple. Negative infinity to positive infinity, everything works. And my set builder, you just stop right there. So you'd say for all x such that x is a real number. So there's no exclusion. So you just say pick any real number you want. And that's what x is. So that's the special case. There are some times when the denominator can never equal 0, and a positive plus a positive is never equal to 0. Not possible when you add two positives. Okay, the last two are the same. The only thing that makes them 0 is when x is 0. 0 times 0. So only thing x can't be is 0. So both of these will be the same. And I'm just going fast because we only have a few minutes, and this is a real simple one. So for the interval notation, it'd be negative infinity to 0 united